Alright, today's lesson is called Evaluating Definite Integrals by Substitution. So there aren't any new note cards for today because essentially what we're doing is taking what we've already learned about definite integrals and what we've already learned about U-substitution and merging those two concepts. So the first example that I want to do with you is the integral from -1 to 4 of 5 minus 2x to the 8th power dx. Now this problem is an example of one where it's going to tell you not to actually evaluate the integral, just to express the integral in terms of u. And you're not going to have very many like that in your homework, but it just is kind of like doing the beginning steps of this problem. So, the first step is to figure out what the inside function is, just like we did with our other U-substitution when we were doing indefinite integrals. And this one's pretty easy to identify. U is 5 minus 2x. So then we're going to proceed just like we have done before. Du dx, the derivative of u with respect to x is -2, multiplied by dx on both sides. And now, since there is not a -2 in the problem already, we'll multiply both sides by -1/2 to isolate the dx. So, normally, now we just go in and put in our u substitution. Here's the thing that's different when we're doing it with a definite integral. Our limits, the -1 and the 4, are going to change also. So to change those, we're going to say, what is u of -1? That means that I'm going to plug -1 in, or substitute -1 in for the x. So it's going to be 5 minus 2 times -1. And that's going to be 5 plus 2, which is 7. So my -1 is going to change into a 7. And now the 4. U of 4 is going to be 5 minus 2 times 4. So I'm plugging my upper limit in for the x in my u equation. So this is going to be 5 minus 8, which is -3. So now I'm going to go back and I'm going to rewrite my integral as the integral from, instead of -1, replace it with 7, and instead of 4, replace it with -3. My 5 minus 2x is going to be replaced with u to the 8th power, and then the dx will change to a -1/2 du. Okay, now the only thing that's left to do is to clean this integral up. We do not leave the integral with the smaller number on top, so you're going to have to put a negative in front and reverse those limits. So -3 goes to the bottom, 7 goes onto the top. And then the only other thing to do is to take that -1/2 and pull it out in front of the whole integral. That will be multiplied by the negative that's already here, so that's going to become +1/2 times the integral of -3 to 7 of u to the 8th du. And since this one was just saying to put this in terms of u, we can quit there. This is the answer to the problem. We now have an integral in terms of only u, and we're not actually going to evaluate it on this one. Alright. Here's example 2. The integral from 0 to the natural log of 5 of e to the x times the quantity 3 minus 4 e to the x dx. So, the u for this problem you might be able to identify as the quantity inside of the parentheses, which is 3 minus 4 e to the x. Du dx would then be -4 e to the x multiplied by dx on both sides, And now if you isolate the dx, you would do so by, oh, actually, we don't want to just isolate the dx because we also have the e to the x here. So we can leave all that together over here and just multiply by negative 1/4 on both sides. And now we need to change our limits. U of the lower limit 0 is 3 minus 4 e to the 0 power, which e to the 0 is 1. So that's 3 minus 4, which is negative 1. And then u of the upper limit, natural log of 5, is 3 minus 4 e to the natural log of 5. And since the e and the natural log are inverse operations, they undo each other, and you're just left with the 5. So this is 3 minus 4 times 5, which is 20. So 3 minus 20 is negative 17. So now I can go back and rewrite this integral with the lower limit instead of 0 being negative 1, upper limit instead of natural log of 5 being negative 17. The parentheses, 3 minus 4 e to the x comes out and is replaced with the u from this. And then the e to the x dx comes out and is replaced with the negative 1/4 du. Now we never ever leave it with the smaller number at the top. So the first thing I want to do is put a negative in front of this integral and reverse my limits of integration. And now I want to go ahead and pull that negative 1/4 out in front of the integral. When I do that, I multiply it by the negative already there, so it'll be positive 1/4 times the integral from negative 17 to negative 1 of u du. So, let's see. I'm going to recopy that on this next page to continue this. Oops, 1/4 in front. Negative 17 to negative 1 u du. Okay, so when I integrate this, I do power rule backwards. So that's going to be u squared times 1/2 times the 1/4 already there, and this will be evaluated from negative 17 to negative 1. This is 1/8 u squared evaluated from negative 17 to negative 1. So plug in my upper limit, subtract what I get when I plug in my lower limit. So this is going to be positive 1 times 1/8, which will be 1/8, minus positive 289 over 8. We have a common denominator here, so we subtract our numerators. And this actually does divide out. Negative 288 divided by 8 is negative 36, which is the answer. Okay. Next example, example 3. The integral from 1 to 2 of dx over x squared minus 6x plus 9. Now this is an example of one where it might be a little bit more challenging to identify what u should be. One hint on this is try factoring that quadratic trinomial. And of course this could be written as 1 over that with the dx over here. They've put it on top. It means the same thing. Factor that quadratic trinomial. X 3 minus, which means the same thing as 1 over x minus 3 squared dx. Now, that could also be written as x minus 3 to the negative 2 dx. And now it's probably a lot more easy to identify that the u for this particular problem is x minus 3. The derivative of u with respect to x is 1. Multiply by dx on both sides, du equals dx. U of 1 is, for our lower limit, plug the 1 into the plug the 1 into the x place in our u equation. 1 minus 3, which is negative 2. And u of 2 is 2 minus 3, which is negative 1. So now we're ready to rewrite our integral as the integral from lower limit of negative 2, upper limit of negative 1. Then it would be u to the negative 2 power times du. Now we do need to reverse our limits of integration and put a oh no we don't. Negative 2 is smaller than negative 1 and it's already on the bottom, so we don't have to reverse them this time. So we are actually ready to go ahead and integrate, which I will do on the next slide. Recopy it first. So, power rule backwards, add 1 to my power, multiply by the reciprocal of that. This would be the same thing as negative 1 over u. Plug in my upper limit, subtract what I get when I plug in my lower limit. This is going to be positive 1 minus positive 1/2, which is 1/2. And that's it. Okay, now for number 4. The integral from 0 to pi over 4 of the square root of the tangent of x times secant squared x dx. Now, what is u? U is going to be tangent of x. How did I know that? It's under the root for 1. For 2, this is its derivative sitting right here behind it. So, du dx is equal to the secant squared of x. Multiply by dx on both sides. And since I already have all of that there, I don't need to do anything else. But I do need to take my limits and change them. U of my lower limit 0 is the tangent of 0, which you will remember from pre-cal is equal to 0. U of pi over 4 is the tangent of pi over 4. And again, from your unit circle days, that equals 1. So this will change to the integral from lower limit 0, upper limit 1 of the square root of u du, which could be thought of as u to the 1/2 du, at which point you can use your power rule backwards. U to the 3/2 times 2/3 evaluated from 0 to 1. So this is 2/3 of 1 to the 3/2 power minus 2/3 of 0 to the 3/2 power, which is 2/3 minus nothing, which is 2/3. Okay, example 5. The integral from 1 to the square root of 2 of x times e to the negative x squared dx. So, what is the inside function here? What is our u? Our u is negative x squared. Du dx is negative 2x. Multiply by dx on both sides. And you can see we have the x and the dx, so we just need to get rid of the negative 2. So we'll multiply by negative 1/2 on both sides. U of 1 is negative 1 squared, which is negative 1. U of square root of 2 is negative square root of 2 squared, which is negative 2. So this will change to lower limit of negative 1, upper limit of negative 2, e to the u, negative 1/2 du. First thing I notice is that my limits are in the wrong order, so I'm going to reverse them and put a negative in front. And now I'm going to take that negative 1/2 and pull it out in front. So that's going to be 1/2 times the integral from negative 2 to negative 1 of e to the u du. Now that's the easiest function to integrate. Going on to the next slide here. Copy what I just had. This is going to be e to the u, multiplied by that 1/2 in front, evaluated from negative 2 to negative 1. Plug in my upper limit, plug in my lower limit. Now, technically that could be considered done. However, we usually don't leave negative exponents, so a better way to write this would be 1 over 2e minus 1 over 2e squared. That's that. Okay, we have one more example to do. Example 6. The integral from pi squared to 4 pi squared of 1 over the square root of x times the sine of the square root of x dx. Now, what is the inside function here? It is square root of x. So u equals square root of x, which could also be thought of as x to the 1/2 power, and the derivative of u with respect to x is 1/2 times x to the negative 1/2 power. Now, I might want to rewrite that without the negative exponent, 1 over 2 square root of x, then multiply by dx on both sides. Now, as you can see, we already have this 1 over square root of x here, and the dx, so all we really need to do is take care of this 1/2 by multiplying both sides by 2. 2 du equals 1 over the square root of x dx. And then I'm going to have to change my limits, which I'm running out of room to do. Let's see. I'll just do that down here at the bottom. U of pi squared is the square root of pi squared, which equals pi. And u of 4 pi squared is equal to the square root of 4 pi squared, which is 2 pi. So my new integral will be lower limit of pi, upper limit of 2 pi, and then sine of u, and then the 1 over square root of x dx will come out, and 2u will go in its place. 2du. And then of course that 2 can come out in front of the integral symbol, which I'll do on the next slide. So what is the integral of the sine of u? That's going to be negative cosine u. 2 still out in front, evaluated from pi to 2 pi. So this will be like negative 2 cosine 2 pi minus negative 2 cosine pi. And that's the same thing as negative 2 cosine 2 pi plus 2 cosine pi. What is the cosine of 2 pi? Remember 2 pi is the same as 0, so that's going to be a cosine of 1. Oops. Excuse me. The cosine equals 1. Cosine of 2 pi equals 1. Plus 2 times the cosine of pi is negative 1. So this is negative 2 plus negative 2, which equals negative 4. That's the answer. Alright, on your homework assignment, there's selected problems from the textbook. Please note that on problems 9 through 17 odd, they tell you to do those problems using 2 different methods. I just want you to do the U-substitution method that you learned today. Don't worry about doing those problems twice. The U-substitution method is what we're trying to nail down today. So, I hope that you felt like this was a kind of an easy lesson, just combining your U-substitution with your definite integrals. There's not much new today other than that you have to change the limits of integration based on your U value. And you never go back and re-substitute the x's into the problem. You just leave it in terms of U for the duration of the problem. So, I wish you the best of luck. Bye-bye.